Welcome to the CAD Office Training Guide series for FDOTConnect. I'm Todd Holt, CAD Applications Training Coordinator. Today I'll be going through the Roadway Design 2D Basics Guide. In this series of videos, I will take you step by step through each exercise from the guide. Today we will start with Chapter 3 of the guide. This guide will go over the fundamentals of 2D design, 2D photometrics, and profiles. Participants will be introduced to the Bentley Open Roads Designer Connect Edition, Open Roads Technology Tools for Design, and modeling, specifically for an FDOT project, using the FDOTConnect workspace. Several new technologies will be introduced, including civil elements, civil features, civil geometry, design intent, design standards, civil AccuDraw and civil cells, Explorer, the civil model, context menus. Let's begin. Topics covered for this presentation will prepare for a State Road 61 profile. We'll create the State Road 61 profile. We'll then edit the State Road 61 profile, and we'll build a profile for the Baseline 98 and the Friendship Road profiles. Let's begin. Quick introduction for this chapter. So this chapter will continue to use Open Roads Technology Civil Tools. We're going to use vertical geometry. So if we go to the Geometry tab, instead of horizontal, we're going to use vertical geometry. These exercises will provide participants with a practice using the civil tools using civil rule-based feature definitions, assures design intent is incorporated into the vertical geometry layout. This will be beneficial for design when changes need to be evaluated throughout the development process. This chapter introduces important new open roads technologies for creating vertical geometry line work. There's a table on 3.2 that we're going to use for design intent, which says the design geometrics and criteria is from the FDOT Design Manual, or the FDM, Part 2, Chapter 210. Design speed will be 45 miles per hour. The facility that we'll be using is low speed desired length. Our maximum tangent deflection without curve is 1 degree. The minimum horizontal radius is 694 feet. And the minimum length of the curve will be 675 feet. But our context class that we're going to use to help us design the profile will come from C3 with a max grade table from 210.10.1. So exercise 3.1 is preparation for State Road 61 profile. Step 1 is we open the ALGNRD01.ggn file that was created in exercise 2.1. In our C work sets FDOT, the 220-495-55201 under bar CE from the Roadway folder. We're going to go ahead and open the reference dialog, and we can do that by the function key F9 or coming into the Home tab, the primary group, the attached tools, and that will open up our reference dialog. You'll notice in the reference dialog I have the SERV-RD attached 4 different times, so I'm going to turn off the topo. So I'm going to turn that display off. We want to leave the SERV-RD with a logical name of GDTM on, but we're going to turn everything else off. So all we see is our alignments and our boundary for the existing ground. So once I have everything else off except for the SERV-RD with a logical name of GDTM, I'm going to go to Properties and then bring up the level display. And then I'm going to select in my level display, which is View 1, the reference of the GDTM. So I'm going to turn everything else off in this level display except for the DTM EP and the DTM EX. So I'm going to go ahead and turn everything else off except for the DTM EP and the DTM EX. I'll close that and then close the reference dialog. I'm going to bring back up my element selection tool, and if I hover over the boundary of the existing ground, I want to pick on this boundary to bring up the context menu. This will bring up the context menu, and I want to set the active terrain, or set the terrain active. So I click on the second icon, so set as active terrain model. What that'll do is create a 3D model in our alignment file. And now, once we have that, we're at step 4. So I'm going to right click and hold so I can get to the view controls. Now I'm going to go scroll down in my view controls. We want to open up 3 views, a plan, a profile, and 3D. So this will ask us to open a dynamic profile view, so I'm going to select OK. And then following the prompts by my cursor, locate the plan element. That's going to be our alignment. And then select or open view. So I'm going to select in view 4 to open my profile, or yes, open my profile view. And what we should see once view 4 comes active is our existing terrain along our center line. So let me go ahead and click in view 3, which is my default 3D. We may have to click on in the view 3, the default 3D, and go to the level display. And we may have to turn on the serve RD for that. If that happens, we want to turn everything else off except for the DTM EP and the DTM EX. And then once we have these 3 views set up, if I fit view in all 3 views, I'll go and save settings. So that's going to set up our alignment file with a plan view, which is view 1, a default 3D to view our profile in 3D, and a profile view along our State Road 61 center line. That's going to move us into exercise 3.2. So in this exercise, several vertical geometry tools will be used to create the proposed profile for State Road 61. We'll go to the Geometry tab, the Vertical group, and use these tools. The other way to bring up these tools is if we click in our view 4, which is our profile, we can go ahead and use the tools, vertical geometry tools, that are associated with this, and even open that up as a toolbox that we can dock. So this group of tools here, if we hold down on that, will have the same names and the same tools as this vertical geometry tools. So either way, I'm going to go ahead and close that. So since I'm in my profile view, I'm going to open up this dialog here and click on that split button. We wanted to use the vertical geometry tool of define profiles by best fit. And that can be located from our view, which is here, or if I go to the Geometry tab, the Vertical group, and go under Complex Geometry, I can find Define Profile by Best Fit. That'll bring up our Best Fit profile dialog. And in this dialog, we're going to set up the parameters first and then use what we need. So we'll set the tool up, and then we'll click on our feature that we want to design a best fit profile from. Make sure my feature definition is on center line. Then I'm going to set this to set as active, so use my active feature definition. So this will take us to step 3A of the guide. So at the cursor prompt data point to make the complex element option, enter the profile name. So we'll enter a profile name of State Road 61. So it should be CL underbar State Road 61 underbar PR for the profile. We'll set the upper envelope. So if we double click in this, we'll set that to 2. So what that'll do is create a 2-foot envelope above. The lower envelope, we want that to search to minus 2.5 below the profile. The desired crest curve length will be set to 300, and then the desired sag curve length, we'll set that to 200, and then the minimum curve length, we'll set that to 150. So again, we're setting up the tool. So we want best fit to make complex element. We type in our upper envelope of 2, our lower envelope of minus 2.5, a desired crest curve length of 300, and desired sag curve length of 200, and use a minimum curve length of 150. So we have this set up, and then we'll click in our view for our profile, and it'll just work its way through the tool. So we'll left click data point and locate our profile to fit. That will be our existing ground along our State Road 61. Before we do that, I missed one step. So we need to go, so before we do our best fit, we want to come up and set our design standard. In order to do this, we need to go to our horizontal tab, which is the first one, and we'll go to the low speed desired length and set that, make sure that's set to 45 if it's not. Once we set that, we could come to the vertical, and we want to do the C2, C3, C4 curb and gutter from the FDOT Design Geometrics Criteria Design Library. So we'll click on that plus, and then we'll pick on the 45 miles per hour. So this sets our horizontal design standard. This will set our vertical design standard. And then we want to toggle on the active design standard. We can then come into, or go back to our vertical tools. From our geometry tab, the vertical tools for the group, go to the complex geometry and select the define profile by best fit. We'll fill this out to the parameters of an upper envelope of 2, a lower envelope of minus 2.5, the desired crest curve length of 300, and a sag length curve of 200, and a minimum curve length of 150. We'll set the name to CL under bar SR61, and then give it a suffix of PR for profile, and then tab out of that. So that's set our tool up. We're going to apply the design standard. We're going to have an upper envelope of 2, a lower envelope of minus 2.5, desired crest curve of 300, or sag curve of 200, and the minimum curve length of 150. So we'll then click in our view 4, which is our profile view. Left click data point is to set the parameters to best fit. So we'll left click on there. And then following the prompts by our cursor, we'll locate the profile that we want to best fit. And that's going to be our existing ground profile along our State Road 61. So select that and highlight it on the existing ground. You'll start seeing the parameters that the tool will work through. So there's our upper envelope, there's our lower, the desired crest curve and sag curve, and then the minimum curve. So once we have that, we'll start seeing, or we'll see a best fit profile. We can then hit escape to get out of the tool. So then we can, from this point, we can select on our profile, and we'll notice that we have read only is set. And if I bring up the properties of it, of the profile, we have a best fit, B-spline, but our design standard did not get applied. So we've laid out the design, our profile, we've selected our desired length. For the vertical, we set our horizontal. Our horizontal, we set the vertical. We then want to come in and select our best fit profile. So we'll toggle on the set active or set design standard, and then we need to select in our profile view the profile that we just did a best fit. So we'll select that. We'll notice once we do that some warnings and error glyphs that show up. To check these, we'll need to go to the Open Roads Modeling workflow. We'll go to the Geometry tab, and then the General Tools group. We'll select on the Standard Split button. We want to open up the Civil Message Center like we did in our horizontal. So we'll go ahead and select that. That will bring up our warnings and errors and messages. We can turn off the microstation, but then we can expand out our elements and our descriptions of our error and our warnings. So our first error, which is the red X, and we can right click and zoom to that error. So that'll bring that into focus. Is the sag is less than minimum. So our design standard value should be 79 feet, but the actual value is 73.15. So we need to set the value to 79 for that to pass. And then we have a slope is less, another warning, which is this one, to change those. So we can minimize that. We've got our two arrows. So we need a slope is less than minimum. For the design standard, it's 3%. Our actual value is 1.97%. So on this slope is incorrect for this design speed. So if we bring these into focus, go to our view 4, come back to the element selection tool, we'll notice that these are read only. So to set that and to make the cursors a little bit bigger and easier to read, like we did in our first exercises when we were designing our profiles or horizontal, we need to go back to what's called the backstage. So we'll go to File, we'll go to Settings, we want to go to Preferences and bring up our preferences for FDOT. We'll go to the View Options Civil. And by default, our manipulator settings are set to 10. I usually make this 25. And then the font scale is set to 1. I'll change that and bump that up to 1.3. I'll also come into my colors. So the read-only color is set to gray. I like to have that set to red. And then the property pane selected, I'll switch that to a light color, so a cyan, and then my selected color, I'll set that to green. And this is all preferences, how you want this set up, but it's just for me, it's easier to read the read-only color to red. So again, in this dialog, we've got the manipulator setting, the size is set to 25, and then the font scale is set to 1.3. So I'll click OK. And then I'll come back and save settings. So now that we'll see that these font sizes are red for the read-only. So that's all read-only in there. So if I deselect it and reselect it again, like we did in previous exercises, what we'll need to do is select and then right-click. Now this tool or this is going to work a little bit different, because we can't edit these. But to fix these, what we'll need to do is select the profile, and then we want to come to the fifth icon over, Convert to Profile Rule, and click on that. That'll make these editable. So now we can edit this profile. So if we go back to our Civil Message Center, we have an error for the sag is less than minimum. For this design standard, it's supposed to be 79. Our actual value is 73. And then our slope is less than the minimum. So it's less than 3%. The actual value is 1.9. So let's fix those two things. So here is our arc. So this is 73. This should be set to 79. So I'll just type that in. It's corrected. and then I'll come over to the slope, and if I zoom into the slope, you'll notice that this is still read-only. What I want to do is right-click on my profile, and then this can be editable. So I want to make that minus 0.3 to fix that, and then that glyph will go away. So if you have glyphs on the warnings or errors on a profile, whether it's or vertical, your horizontal geometry, or your vertical profile, you bring up your Civil Message Center. That can be found in the General Tools, Standards, and the Civil Message Center. And then you can bring that up and pin it if you want, or just leave it undocked. And then in the Civil Message Center, if you right click, you can zoom to those error messages. That'll zoom in to the view that is going on. So a new tool to preview in OpenRose Designer is the Table Editor. And this can be found on the OpenRose Modeling Workflow, the Geometry tab, the Common Tools group, and a Table Editor. So if you click on that, it's going to ask you for the alignment. We can either pick on our horizontal alignment, and it'll show the parameters of that, or we can pick on our vertical alignment. So let's pick on that. And that is another way that you can edit and fix your geometry. We'll get into that tool a little bit later. That will take us to exercise 3.3, where we're going to edit the best fit profile that we just laid out. And this is another way. If you go to your table editor, we could go in there and fix our sags and crests and our vertical RK values on the sag. So we could check in this and fix that. You'll notice if you select over in the element, it highlights where that's applied. And then you would have to click apply to change that. So what we want to do is select on our profile. And if you haven't already, which we did to fix these, our glyphs or our warnings, is you would select it and remove the profile view, or convert to profile rule, which we already did that in the last steps. So we need to start deleting some PIs. And we can do that one of two ways. I'll go both ways there. So if we go to our Drawing tab and our Modify group, we want to delete Vertex. So again, we're on the OpenRose Modeling Workflow, the Drawing tab, the Modify group, and we'll click up on the Delete Vertex. And then we want to come back down in our view folder for the profile, and we'll select the start of the line and then our endpoint in our profile. So we'll just start deleting lines in there. You may notice a construction line element that's replaced in here. That's fine, we can delete that again. We'll just that's just a ghost element left over. So we'll go back to our element selection and delete that element on there. So once we have those deleted, we want to start designing our profile again. And we're going to go to our Geometry tab, our vertical geometry, and we want to do the profile line between points. But we need to set our feature definition first. We can do it in the tool, or we can come up to our feature definition toolbar and set it active. And we can use the match feature definition. So we can just match our feature definition and just select in our profile of our profile element to put it on the correct feature definition. And then we'll toggle on use active feature. So that'll give us the centerline feature to draw our line between points for vertical. Alright, so we're going to go ahead and use our vertical tools. We want our profile line between points. And then we're going to zoom into our intersection of US 98 and the school entrance. So this is the school entrance crossing US 98 going to our new State Road 61 that we designed. So we want to trace over, and these doesn't have to be perfect, but we want to trace over our lines. So we'll do a trace over that and then trace over from this. So we've traced over our US 98. And this is exercise. Our next tool, what we want to do is our line between points, but this time we're going to check on the length and the slope. And we want to do a length of 250 feet, and then our slope will be a negative 0.3% and then tab out of that. We can put a name in there for CL. We'll just do a underbar PR and then tab, so we've set the tool up. And then we want to snap to the line that we just placed and then draw that out. So we're placing a profile line that's with a length of 250 and then a minus 0.3%. So that will give us our line. And then the ending point that we want to put in is we want to snap to the end and then just snap to that. So that's designing over US 98 and then using a 250 foot line with a 3%, and then we'll connect our PI to our curve. Our next tool that we're going to use is on our vertical tools. We're going to do profile complex 5B PI, and that can be in our profile view, our profile complex 5B PI down in there. That'll set it up. Bring up the parameters. We're going to set the curve length to 50 and then enter, or we can grab that from the vertical group on our ribbon and go to the complex, and this one is profile complex by PI because we're already in the vertical tools. So from the vertical tool group, we can do profile complex by PI. We'll pick on that. That's going to bring up the same dialog, and we'll check on the curve length. We'll set that to 50 and then give it a name of underbar PR and then tab. So we've set the tool up for a curve length, and then we'll zoom in to our start, and we want to snap to the start of our profile and then just go a little bit beyond, and then we'll snap, and that'll put our curve in to our profile. So that'll put our curve in there. So once we have that, we'll right click out of that tool. So we've got that drawn in, we've got our profile. The next step is to zoom to our end, so I'm going to right click to end the tool and then hit escape and F6 just to make sure I'm out of the tool. And then I will zoom out and zoom into our end of the profile, and we want to select on our profile line, and then we want to grab the handle and move that up to tie back into our existing. Alright, so our next step is to profile or complex this profile all together. So we will come back up to our tools, so deselect, and we want to toggle our active profile, and then we'll go to our vertical geometry tools up here, our complex geometry, and we want to profile complex by elements. We want to set our method from manual to automatic, and then our maximum gap, we'll set that to 0.03, and we'll give it a name of CL underbar SR61 underbar PR. So we'll have a centerline State Road 61 profile, and then tab that out of the tool, and we'll zoom down in to our profile, and you'll want to make sure, just hover over that, so you'll see I get an arrow in the direction that the profile will be complex together. If we're doing manual, you want to make sure all your arrows are in the same direction, and that changes dependent on where you pick on the line. So that may change. So if I pick my first element, which is the profile coming out of the school, if I select that, it's tracking automatically down the profile. It doesn't have any more, so I'm going to left click and data point to accept. So now we have a complex element with our name. Hover over that of State Road 61, and it incremented it. If I want to check the element on here or check the report, I can hover over, select the line, bring up the context menu, go to the profile report. So that's the profile report. That'll bring up a vertical alignment review report where I can review the information from it, just like we did for our horizontal. If the stationing is not correct, we'll want to come up to the tools and format options, and we'll go to our station group here and set our format. So we'll do the SS plus the SS and then close. That'll make our stationing correct, but we can review the numbers on this report. So once we have that done, so once we complex that together, we'll want to, if we did not, apply a design standard to it. So our horizontal will be set to 45, the desired length 45 miles per hour, and then we'll need to come into our context classification for the vertical, and that's going to be C2T, C3, C4 curb and gutter, and that's from our active, and set that to 45. And then we'll toggle on set design standard. And we can go ahead and select our profile that we just designed and complex together. And you'll notice inside our entrance, or coming out of the entrance of the school, we have some error messages in there. Those can be ignored because you're not going to hit 45, but that's just to be aware of. And to see that, we'll come back up to our General Tools. We'll go to Standards in the Civil Message Center. Again, we'll turn off the microstation, and we can come in and play and look at our warnings and errors. So we have one error message, crest is less than the minimum. That's our 98. That's coming out of the school. So for this design speed, that's okay. The rest are warning. 3%, 0, we can change those in our profile. So if we come in and select on our Civil Message Center, on the error, we'll zoom to, that'll take us to our error. So here's the error, that length of this line. It should be 98, it's only 6.8, but we're coming out of a school entrance, so we're not going to hit the 45 miles per hour. We can turn those off and turn the errors off. by just clicking on them for glyphs. So if we still have those when we do the plans production, we would want to turn that off in our alignment file so they don't show up in our profile sheets. And that can be processed for clipping sheets, can be found in the plan development workflow guide that we have. So let's turn back on the warnings and look and see what we have. So we have a couple different warnings here. One is our slope. So we have a 0%, which should actually be 3. That's an easy change. We'll go to the element select and select that. And again, you'll notice that these are read only. So if I right click on that, so this should be 0.3. So I'll change that. That glyph will go away. And then come here and select on this guy. And that, so this is our slope coming out of it. That right click. I don't know if we'll be able to change this one. Probably not, but it's coming out, so I think we can ignore that one. That would be up to you as an engineer to see what you can, in your design of your profile, to make sure it's within the design and make that engineering judgment. If it's not, this is coming out of the school entrance, so you're not going to be up to 45 miles per hour coming out of an entrance. So I think those are okay, so I'm going to turn those off. So I did show the profile report. The next step is our profile. So what we'll want to do, we'll pin my civil geometry or the civil message center. So you'll notice in the 3D view up here yet, so we want to set that. So I will select on my profile, I hover over it, and I'll set as active profile. So now we have a profile view shown in our 3D. And we have a profile that is associated with our horizontal. If I want to do a backup of this, which we recommend, we want to save that as an XML. We'll go to the General Tools group, to the Import Export Split button, and we'll go to the Export Geometry. It'll then ask us to set the parameters for the tools. So the type, we'll do XML, so we'll left click data point and then locate the elements and then reset to complete. So we want to locate our State Road 61 center line that we designed, horizontal and vertical. We'll select that. I'm done with this tool, so I will right click to reset. It's going to save it as a land XML version 1.2. So do that, and I'll just left click. Just a note for this tool is saving the only active profiles. That's fine because I have one profile. If I have more profiles, instead of this being set to yes, I would want to toggle this to no, because I can have multiple profiles on any single alignment. If I have this toggled on to say yes, it's only going to save the active profile. So if I had alternate profiles that I wanted to save to land XML, I would toggle this so it says no, which I don't. So it will save it out to our roadway file and save it as the alignment name. In this case, it's incremented it up to 1 because I already have one file in there. But this would be our CL underbar SR61. We would then click save. I'm going to click cancel, but you guys would click save to save that out. So that is exercise 3.3, where we edited and designed the profile. Baseline 98 profile. So I'm going to switch my feature definition to baseline, or I can match my feature definition. So I'll select on that. That's going to set my feature definition, and then I'll toggle on to use active feature. I'll go back to my element select tool, and then I'm going to zoom in to my US 98. If I hover over that line, you'll notice that it does not have an active profile from the context menu that pulls up. So I'm going to select that line, and then I'll bring up a context menu. I'll go to the second icon to open profile model. So I'll select that, and then following the cursors, I want to select or open a view. So I already have a view open for my profile. And then you'll notice up in our 3D, so for this existing ground line, I want to set that active for our US 98. So I'll select it, hover over it to bring up the context menu, and then set as active profile. And you'll notice in my 3D view, a new orange profile line will come up. And again, to save that, I can come to my import, export, and then export the different types, plain XML. I can select all my alignments that I need to. So let's repeat that process for the Friendship Road. So we have that, or any other alignments on there. So our Friendship Roads, they're going to match the existing. So let me cancel out of that tool. I'll want to set my feature definition back to the center line. So go to match feature definition and select that. That's going to change it back to center lines. I'll then bring up my element select tool and select and hover over and click on the second icon to open profile model, and then select in there. And in my 3D view, you'll notice I don't have any profiles for my Friendship Road until I select on my existing ground in my profile view and toggle on or set active profile active. So we do that for the Friendship 2. Again, I'll select in my plan view, open the profile model view by my context menu and select the view to open. I'll select on my existing ground and then set as active profile. So you guys can repeat that for any other lines in here. But that brings us to the end of chapter 3, where we design profiles for our center line. So thank you for joining me today, the CAD Office series for FDOTConnect. Today we went over chapter 3 of the Roadway 2D design basics. You'll see in any questions, go ahead and email CAD support and check out our training guide resources or links, and if they're at the CAD webpage. Thank you again.